Good morning, physics. We got our 2D momentum. It's early. It's 8:30. I just got here. So, but yeah, 2D momentum. We're gonna go over that right now. Looking at, again, we have this conservation of momentum, and we did that in our last video, looking at when things collide or when things hit each other and stick, that the momentum before the collision, the momentum after the collision have to stay exactly the same. Okay, or an explosion, which means that it starts as one and then separates. Okay. That has to do the same with direction, okay? If something has a momentum going north and then all of a sudden goes west or goes south, that's a massive change of momentum, and so something had to create that, okay? Either an impulse from an outside source creating a force, or a collision with something else, okay? So with these videos, I'm probably gonna break it into two videos. I was gonna do it all in one, but it'd be a really, really long video, so I'll break it into two, that way you get a little break of me if you need. We're going to look at the change, or sorry, the conservation of momentum, but within direction, okay? And so again, we're going to be doing a lot of vector work, our X and Y work, so if you need to go back to combining vectors or advanced vectors, get a little refresher, please do that. All right, let's look at our first question. So this is from the, what's this called? This is called 2D momentum. So the worksheet that's called 2D momentum, questions 1 and 4 I'm going to do first. So if you want to grab a look at those, we'll do these ones first. All right. So it says a 31 kilogram baseball, okay, is moving horizontally at 41 meters per second, and then it's hit back at the pitcher. So let's just kind of draw this out. It doesn't matter which way you draw it. We're just going to draw the ball going this way, 41 meters per second. It says straight horizontally, so no no Y component whatsoever right now, just an X component. Okay, it is then hit back in the direction of the pitcher, so basically the opposite direction, at an upward angle of 30 degrees, okay, at a speed of 53. So if it was hit right here, it'd be kind of going like this, 53 meters per second. Again, we have 30 degrees. Okay, I'll kind of put 30 degrees over here as theta. It says find the impulse given to the ball. So basically, again, this batter gave an impulse, okay, to the ball, and so that was, they hit the ball. We want to know, like, what was that change in momentum? What was that impulse given? Again, impulse is our change in momentum. Now, when I draw it like this, it looks like I have to find this kind of vector, okay? We go back to our advanced vectors, if you know the initial and you know the final, you need to find, like, the middle part. So I'm going to redraw this one to make it look like this. And I know the ball was not hit, okay, from where the pitcher was, but it's a lot easier to do this because then I know that I need to find this. I need to find that vector, okay, because not only did the ball speed up, it sped up in a different direction, a totally different direction. So I need to know this magnitude and this direction, okay? And so what I need to know basically is I need to find this X component and this Y component. Those are the two things that I'm going to need to find what was the change of momentum. All right, so let's do that. So momentum initial, 41 meters per second, and in the X direction, no problem. Let's break this apart, okay? And so let's break this up into our, basically our momentum X and our momentum Y, okay? Actually, I'm not going to put that. I'm going to put down velocity X, velocity Y. Okay? If I said momentum, I'd have to add in the mass right now, and I really don't want to. You could absolutely say momentum X, momentum Y. It doesn't really matter, but I'm going to put velocity X, velocity Y. All right. So when I do this, okay, again, if you think of this, this is going to go back to on your formula sheet when you look at dynamics, it says finding Fx, the force of X, or Fx, or Fy. To find the X component, this is cos, because it's adjacent, ka, okay? You have an adjacent and hypotenuse. To find this side, it's sine, okay? So just as a reminder, I'll put these here, okay, to find Fx or Fy, okay? Sine theta times the force applied, okay, or the velocity applied. And for the Y, it is, my bad, woo, this is cos, cos. Hey, how's it going? Yeah, I'll be there in 2 minutes.
Okay, all right.
Yeah.
I walk by. Yeah, I'll be around.
No problem. Okay. So force x, sorry, is cos adjacent, and then our y is our sine or opposite. Okay, cool. So let's break this apart quickly. If I do basically like sine, we'll do y first. Sine of 30 times 53, I get 26.5. So here's our 26.5. If I go cos of 30 times 53, I get 45.9. Oh wait, meters per second. All right. So I've broken that one apart. Now, what was my change in velocity? Okay. So my x change velocity was 45.9 plus the 41 because it went opposite direction. If it was going the same direction and just sped up, that's different. Okay. Because then we minus these two. But because it's going the opposite direction, that's my change in momentum. So 41 plus 45.9 is 86.9. And my change in velocity y is just the 26.5. Okay, so now to find my overall change in velocity, my overall, again, a squared plus b squared equals c squared. And so my overall change, my change in velocity total is 90.85 meters per second. Okay, so that is my change in velocity. All right, I have to find a direction still, but let's leave that alone right now for 2 seconds. I'll find the angle in just 2 seconds. It says find the impulse given. Again, impulse is the change in momentum. So I have the change in velocity. The nice thing is all I have to do to find the change in momentum is just multiply this by 0.31. So when I take the 90.85 and times it by 0.31, I get a momentum of 28.16 kilograms meters per second. So there's my change in momentum. Now let's just find the angle that it actually changed at. Again, to do that, we're going to take these two components, okay? Because what did my change in x, my change in y? Okay, how do I find an angle again? Just a reminder, I'll put it over here, I don't know why, but I will. To find the angle, okay, it is inverse tan of y over x. Okay, y being your north and south direction, x being your east and west direction, okay? So I have 26.5 over, so my angle is going to be inverse tan of 26.5 over 86.9. A lot of students want to use this 45.9. You need to find the whole change, When I do this tan inverse, like do this, you'll get a decimal first and then actually find it. I get an angle of 17 degrees. So theta is 17 degrees. So the total impulse given is 28.16 kilogram meters per second at 17 degrees. That's what the actual change was. That's what the batter did over here. Okay? A little longer to kind of find some of the conservation here, but working it through. All right, let's go to question 4. Question 4. Question 4, it says, a 1,100 kilogram vehicle traveling west, so it is traveling this way, 17 meters per second, subjected to a 1 times 10 to the 4. I want to say in some of your guys' worksheets this 4 was big. I'm sorry if it is, it shouldn't be big. It should be like a squared, like not squared, to the power of 4. Which basically means, again, just times it by 1,000. Okay, so, so you should have 4 zeros basically. So basically there's an impulse of 10,000. Okay, and it is an impulse this way. Okay, of 10,000 kilogram meters per second. What is the magnitude of the final momentum? So what is the new final momentum? Okay, which means, again, we have to find the actual kilogram meters per second as well as the actual angle as well. You don't really technically have to find the velocity in the end, but you have to get what's the final momentum of this thing. Okay, so I have this velocity here. I need to turn this into an actual momentum. So what is the momentum of this vehicle initially? Take that 17, multiply by 1,100, and I get a momentum of 18,700. So this is the original momentum. Now we are adding this momentum in a different direction. Okay, so this is going north. It was going west. So kind of similar thing of what we did before now though. I already know I have an x, I have a y, so I can add these together. First, also like a squared plus b squared equals c squared, and then I can find my angle as well. So I'm just going to take my momentum. The nice thing is as long as they're both momentum, okay, as long as we're talking the same units, I know this says it's an impulse, but again, an impulse is the change in momentum, so we're still talking about kilogram meters per second. This is kilogram meters per second. So as long as we're talking about the same units, we can combine them and make it all work. So that's what we're going to do. A squared plus b squared. Now, I will warn you, when you put this in your calculator, they are very big numbers. So I'm a little sorry for that, but that's okay. A squared plus b squared equals c squared when I end up doing that, okay? And I find my actual thing. I'm going to give you this just to make it nice for you guys. This is the number that you should be getting when you square root it, okay? It is a large number, but it is 4, 4, 9, 6, 9, 0, 0, 0, 0, 0, 0, 0. So that is the number you should before you square root it. After you like square that, put it together, there's the number you should get. And that means you get a final momentum of 21, 205 kilograms meters per second. Okay? So that is the actual change. That's not the change momentum. That is the new momentum. Okay? Momentum final. Okay? You had this, you added this, this is a momentum final. 21,205 kilograms. Okay? It doesn't ask you for the velocity, but if you actually wanted to know, like if there was a part B, hint in one of my questions on the actual assignment, if there is a part B of like, what was the final velocity? All you have to do is just take this momentum divided by the mass, and you get the velocity. So not too bad. Okay, let's find the actual angle. And what angle do we have? Again, tan inverse of our y over x. This being our y, this being our x. Okay, so 10,000 over 18,700. And I got an angle of 28 degrees. 28 degrees north of west. I have very distinct angle, like actual directions here. West, north. The other one, question one, just said it's coming back in the picture, so we didn't really get to give a north or a west or an east, that kind of stuff. This one is very, very specific. Okay, it was going west, has a northward impulse, so I can say 20 degrees north of west. Okay, cool. Honestly, hopefully that question went pretty good. Just understanding how we put these together. All right, class. I'll do one more video looking at question 5 and 7 from the 2D momentum, and then you should be good for the week. Awesome. See you soon.